Okay, guys. Sorry, I came 15 minutes late. I was trying to like answer some other students' questions. Okay, so questions. What questions do you have for me? Anything about the exam, you know, what type, it's gonna be just like Cat 1 and 2, multiple choice, true, false, okay? You're gonna have 2.5 hours. I already gave you the distribution of the number of questions for me and Dr. Pearson. You still have that. Also, be careful, there will be no bathroom break, okay? So you cannot leave the room. What else? Make sure when you finish the exam, you show the proctor, me or Dr. Pearson, you show us the green screen that says congratulations. Make sure you do that before you leave the room. You also have, the scratch paper and a folder to use. You write your name. So as far as policy, yes, ma'am. Antiviral, it's for your own education, antiviral, okay? The same. So, today's topics we covered cell wall synthesis inhibitors, the beta-lactams, and the protein synthesis inhibitors, clarithromycin, tetracycline. The rest, the other two topics, which are the folic acid inhibitors and the antiviral, this is just for your own reading, okay? Yes, ma'am. Two things. So the question is about the C-peptide chain. What is the purpose of this chain? Well, first, without it, we could not make the insulin by itself because it goes A, B, and C connects A with B, okay? So without it, we're not able to make the insulin. Second, it actually helps the shape of the insulin to fold in the correct active conformation. So after it folds, then we can, cut it and just keep the insulin by itself. Welcome. Yes, sir. Okay. Okay. So, so actually on Canvas, if you look at the topics, the ones that are not part of the test, they says optional reading. The only thing I did not update is today's lecture, so I have to add optional reading to that part. And I think there's one thing I did not add on Canvas, that is optional reading. Well, you already voted for the September 29. It's going to be optional reading. So, yes. Okay. So everything we talked about, you only need to know as a pharmacist. Hopefully, you still retain that information. But for the sake of the exam, since the material is a lot, then this won't be on the final. I will go on Canvas and then update the information, see which ones are on the optional reading, okay? And hopefully, if I remember, I'll send you an email. If not, please feel free to remind me, drop me an email. Oh, thank you. Thank you. Thank you so much. He is. Arnold is the best. Any other questions? So guys, the key really to, questions in the exam are what we have seen in the RATs and in the application exercises. And of course, what we have talked about in class, okay? So if you're not sure, just watch the video. It's length, it's a long 3-4 hours, but, you could watch it on speed. Make it fast. I know I will sound funny, but still, if you could just, move forward to the topics that you're not sure if you really want to know. Yes, ma'am. Okay, so for the material, for the 6 questions that covers, you know, the material before Cat 2. If you want to take the short route, I mean, I'm not supposed to say only study this or that, but if you just want to take the short route, you could review RATS and Cat 1 and 2, okay? Then that will give you at least, you know, like solid 70% or 80% of what you need to know. Because when I ask questions on the RAT and Cat, I focus on the most important things I want you to know. But if you have more time to go through everything, then good. Yeah, but remember, some of these concepts, even though, I mean, some of these concepts keeps coming up with the other material, right? So you really need to, you know, keep them. Like, you know, when we talked about empirical approach, for example, how it's used to calculate lipophilicity, we applied that for the barbiturates and benzodiazepines. You can apply it anywhere. Anytime you talk about lipophilicity, then you could use the empirical approach to see which one is more lipophilic. Or you could use a rough estimate and say how many hydrocarbons here, how many carbons here, how many carbons here. You can compare the two structures and see which one is more lipophilic, okay? Okay. What else? Yes. Right. So actually, when I remember asking you guys, and you thought, you know, no, just print the page for us. So I'll print the page instead. Yeah. So I will print. You guys remember when we talked about the what was it? The asthma drugs, the beta 2 agonists, right? So there was some SAR information, and so I will print that page for you with all the information so you could use, okay? Now, in case I have a question on this part, I mean, if I don't, then you don't need it, but most likely I will, okay? Yes, ma'am. Uh-huh. Okay.
You know, some of them are long lasting, some of them are ultra lasting. How is it related to the duration of action? How does it relate?
Right. So insulin. Okay, guys, remember the insulin? How it's, you know, we have different kinds of short acting and, you know, rapid acting and intermediate and long acting. So you need to know that the mechanism and the concepts of how these drugs were made long acting. Can you name the ways, different ways of making drugs, of making insulin have a longer duration of action? Zinc. So you could add, if we add 1 zinc, what do you get? You get, right. So if you add a zinc, then the insulin can form into dimer, and it would stay longer in the body instead of being into monomer, and then it will be released slowly. But if you add 2 zinc atoms, then it's even more complex, and then it stay longer. So I do remember there was, like, I think long and ultra long, or intermediate or long, intermediate and long. Okay, so in the intermediate we had 1 zinc, in the long we had 2 zinc atoms. So that's one way, adding a zinc. What zinc? What else? Say it again. Increase solubility. How's that? So we're talking about, remember, we're talking about extending the duration of action. Yeah, you could add fatty aliphatic chain, right, to make it more lipophilic. That's one way. What else? Protamine. What's protamine? It's a positively charged protein. So just like the zinc, it binds to the insulin and it delays its release. It makes it stay longer. So you have protamine as one way. What else? Protamine is a positively charged protein which binds to the insulin. So insulin must be a negatively charged mostly. So then it forms complex with the insulin and delays its release. So the concept is similar to what we see in the zinc. Okay, zinc is positively charged. Okay, what else? What is it? There was one thing that talks about the isoelectric point. Say it again. Modify the amino acids such that the total charge, the net charge for the insulin is now 0 at 7.4. Okay. Okay. But in that case, insulin will not be as soluble, so we have to prepare it under pH, I think 4. So then when it's administered, it's at pH 7, and then it has 0 total charge. Okay, and then it will not be as soluble, so it will stay longer in the body. Okay. So what about how do we make the insulin ultra fast? Or not ultra fast, sorry, rapid acting. I think there's only one mechanism. Say it again. Okay, so we wanted to stay in the monomer form. How did we change it in such a way that it's in the monomer form? And say again, change the amino acids in the C terminal such that they do not form dimer. They stay in the monomer form, okay? And therefore they could be released faster, okay? So remember the types of insulin we had. We have the short actin, which is this is our standard, the natural insulin short actin. And then we have rapid actin. So for the rapid actin, in order to make it a rapid actin, we modified 2 amino acids such that the insulin cannot form dimer. It stays in the monomer. It cannot form this complex, and it's more soluble. So now it's able to dissolve faster. Okay, so we have a rapid release of insulin. Okay, so they all go in line after. I mean, they all based on the concept of either making the insulin more soluble or less soluble, or make them form complex so they do not get released from the complex. Okay. Okay, so there is one class of drugs, we call them rapid release, and it uses only one mechanism, which has the 2 different amino acids. Was it the Lespro? What kind? Do you guys remember what's the name of that? Rapid Lespro, right? Lespro insulin. The Lespro is the example. Okay. Yes, sir. Sulfur allergy? Okay, so so the table that we talked about in the application, it will be provided to you, okay? And your goal is to look for the blue boxes. So anything within a blue box will cross-react with each other. And what you will see is that the antibiotic sulfa which are antibacterial and antiviral, they will be within the same box, okay? But then you have the non-antibiotic sulfa, they will be subdivided into other blue boxes, okay? So you will see, for example, thiazide, thiazide-like, what else in the same, together in the same group? Was the loop with them? Loop diuretics, was it with them? No? Yes? So loop, diuretics, thiazide, thiazide-like, they're in the same blue box. But then you also have another box that has the carbonic anhydrase. And then another box that has, what else? The, anyway, so your goal is to look at drugs that are within the same box. So drugs within the same box, they cross-react. But outside that, if we have a drug from different box, it's not gonna cross-react with the other one. Now in the loop diuretics, there was one drug that is actually not sulfa. Which one? Ithacronic acid, right? So in fact, it's the only exception among all these diuretics that is not a sulfa. So don't get confused that even though it's a loop diuretic, but it's not even listed in the box, but you should know that ithacronic acid is an exception. So what's the problem with ithacronic acid? I mean, it's nice that it is not sulfa, and we could use it if someone is not allergic to the, I mean, if someone is allergic to the sulfa, but what's the problem with ithacronic acid? Ithacronic acid, I'm not sure I'm pronouncing this correctly, but it's, this is how it says. It's coming, just give it some time. It's not sulfa. It's among the loop diuretics, but it is not sulfa. So if you really have to give a loop diuretic and someone is allergic to the sulfa drugs, this class of drugs, which has, you know, loop diuretics, if somebody is allergic to, let's say, furosemide, then the only one you can give if you really want to give a loop diuretic would be ithacronic acid, which is here. Hopefully you should be able to see it now. Okay, ithacronic acid. Now, what's the problem with this one? It's the least potent among the loop diuretics, okay? So what does that mean? So in order to get the therapeutic effect, you have to give more of this drug. When you do that, you have some side effects. What are they? Ototoxicity, right? Was that the only one? And GI problems, okay? So luckily the ototoxicity is reversible. So as soon as you see it, you can stop and then go back. Yes, yeah, it is reversible. In fact, one of the antibiotics, which we did not get the chance to learn about, aminoglycosides, also causes ototoxicity, which is reversible. So normally you should not combine these two if you ever have to. Question? Okay. So ithacronic acid is least potent among the loop diuretics. Yes, ma'am. Was that which one? Ampicillin? Ampicillin is not for sure, but gentamicin, is that aminoglycoside? Is it? Is it? So it does cause ototoxicity too? Okay. The gentamicin? Okay, I can't remember now, but yeah, I mean, definitely if you have a drug that causes ototoxicity and another drug that also causes ototoxicity, then chances increase, so you should not combine them. So there was something about potency and efficacy of these diuretics. Remember, we had examples where drugs are not potent, yet they are much more efficacious than other classes. Okay, so we looked at examples of thiazide-like diuretics that were actually potent, but they are not as efficacious as the loop diuretics. I hope you still remember that the most efficacious class is loop, right? Now, among the loop, which one is the most efficacious? Actually, the most potent, sorry? Huh? Bumethadine, that's right. Okay. The most potent among the loop diuretics is bumethadine. Now, the loop diuretics are actually the most efficacious among all the other, all the diuretics, okay? So if somebody has GFR, glomerular filtration rate below 40, which means they have severe kidney problem, then you go with the most potent, most efficacious, such as bumetanide, okay, as an example. And I think there are another 2 more examples of drugs that are really potent that you could use when the GFR is below 40. What else? Why cannot furosemide be given for someone who's osteoporosis? Because it's hypocalcemia, okay? So which one of the classes of antidiuretics causes no electrolyte disturbance? Which one? We call them aquaretics, right? But what's an example of the aquaretics? Vaptans, okay? So Vaptans actually have a good future. So there are many researchers working on Vaptans just because they do not disturb the electrolyte balance. What about the antacids, PPIs, antihistamine? Did you master that material very well? No? Proton pump inhibitors and the antihistamine and all that? Yes, ma'am. Oh, Vaptans, this class of drugs, they are called aquaretics, which means they do not affect the electrolyte balance, okay? Unlike the other diuretics, okay? Vaptans, V-A-P-A-T-A-N-S. So like the Conivaptan, okay? They all end up with the term Vaptan. Okay? Questions, guys? Yes. Yeah, I'm sorry. I saw it this morning. I'll answer it. If you want to ask me now, that's fine.
Okay.
Sure.
So with since the PPIs are activated in a location where the pH is less than 4,
Yes.
would it be correct where it says to be activated for the PPIs to be activated, the environment must have a pH less than 2? Would that be correct? Or?
The short answer is no, because pH 3 can still activate PPI. So her question is, well, guys, which pH would activate the PPIs? What pH below which the PPI can be activated? 4, right? So I know one of the practice exercises I was trying to, I guess, being tricky and was saying, if PPI can need to be activated, the pH should be below, must be below 2. No, they can be 3 or 4, or 3.5. As long as they are below 4, they can be activated. The pH does not have to be below 2. Now, luckily, in the Caniculus, pH is 1 or 2, so that's no problem. Yes. Which one? DPP4? DB? Can I see it? Okay, yeah. DPP4 inhibitors. Okay. So right. So so this is the enzyme that actually degrades or destroy the what did you call them? Okay, DPP4 enzyme destroys the incretins, which is GLP-1 and GIP. So inhibitors of this enzyme are good, okay? So I would not, maybe I would not like memorize examples of DPP4 inhibitors because they're not really common, but I could, if I use it, I'll list the name and then in brackets say it's a DPP4 inhibitor. Say it again. The inhibitors, what's wrong with them? Yes, yes, thank you. Yeah, the general mechanism of action, yes. Any other questions? Yes, Daniel. No, only the ones we talked about in class. Okay, so guys, for the diuretics, I know each class, each example has different ways of, hypokalemia, hyperkalemia. I think the major ones I want you to know is like loop diuretics because hypocalcemia, so should be avoided with osteoporosis. And there are 2 examples of drugs that do not cause hyponatremia, and that's why they could be used for patients who have the hyponatremia. Can you name these 2? Vaptans, of course, are one of them. What else? And the osmotic diuretics. They do not. They do not cause hyponatremia. Yes, they do not affect the sodium. See, most of these diuretics, they cause hyponatremia. You know why? Because that's how they get rid of the water. See, whatever the sodium is, the water will follow. So, normally the mechanism of action for these diuretics is to have the sodium stay in the urine such that the concentration or the osmolality is higher. So the water will follow the sodium, and that's how they get rid of the water in the urine. So, but doing that will cause hyponatremia. Now, if someone already has hyponatremia, then you should treat them with other medications, which are exceptions. The Vaptans, which do not affect the electrolyte balance at all, and the osmotic diuretics, okay, because they actually cause hypernatremia, the osmotic diuretics, okay? Yes. Say it again.
Do you remember on page 18 when it had this and then the other stuff on there like this?
Uh-huh.
Is that going to be on the exam, or you can just go down? This is the entire page. It's right there.
Right. So this is the one I was talking about on the beta 2 agonists. Page 18 will be basically provided, printed to you. So you don't have to memorize it, okay? But you need to know how to use it. Yes, and also the page that talks about the sulfonamide allergy, not the whole page, but these two tables together, okay? With the blue boxes, and it would be colored so you can see the blue box, okay? Unless I decide to use yellow box, then just to trick you. What else? So what topics did we also talk about? Okay, the asthma. What else? Say it again. No. So everything we talked about in September 29, it had what? Beta blockers, calcium channel, nitrates. Boy, that's a lot of information. You picked a tough topic. Oh my God. Nice job. I never thought about how much information is in that material. There's like beta blockers. I mean, that's a lot of information. Okay, nice try. I'll get back at you with the other materials, okay? And remember the table, when we talked about the asthma, the glucocorticoids, this table would be provided to you, so make sure you know how to use it. I personally like to use numbers. I don't go by the circle, the triangle, it's confusing, but it's up to you. So the table will be provided. You will see an example of 2 drugs, and then you should be able to compare which one has more glucocorticoids activity, which one is more lipophilic, longer duration of action, or short, and all that, okay? So basically the selectivity to the glucocorticoid or anti-inflammatory, or the anti-inflammatory or the water retention feature. So you will be presented by 2 structures, and you need to compare between them using the table, okay? So you should know which one has more anti-inflammatory effect, which one is a prodrug, which one is not, okay? Remember, guys, the prodrugs are the ones that has which hydroxyl group covered on which position? 21, okay? There's also another case of prodrugs that has the C double bond O or OH, the hydrocortisone and cortisone. Remember, one of them is a prodrug, the other one is not. Just like the prednisone and prednisolone. So make sure you know which one is prodrug, which one is not. Now, if it's a prodrug, it needs the liver enzyme to convert it. So if we have a problem with the liver, guess what? We're gonna use the other one, okay? Not the prodrug, okay? Right, so there are one way of how these glucocorticoids can be a prodrug is if we esterify the OH group at position 21. So you want to check the OH at position 21, and if it's esterified, if it's covered with an ester, then it will be a prodrug. If it's not, then it will be active drug. Now, if we esterify the other groups but not D21, then it's not a prodrug. The other example for prodrug is when we have, prednisone, prednisolone, and hydrocortisone and cortisone. There is one position, what was it, C7? Anyway, so there was one, double bond O that converts to OH, right? C11, okay? So if that position, the OH group at 11 is OH group, then it's active. If it's double bond O, then it's inactive. It has to be converted. Now the enzyme then converts that. Is it the esterase? No, it's something dehydro, something. I'll provide it to you, okay? But that enzyme is present where? In the liver. So if somebody has liver dysfunction, then we cannot use prednisone or hydrocortisone, okay? Because they rely on this enzyme to be converted to the active form. Someone was having a question. Was it you, Sherry? Yes, I'll put the numbers. Yes, ma'am. Because you will need, because the table refers to the numbers, and then you should be able to use these numbers, okay? So there are 3 diseases that whenever you think of glucocorticoids, you should be mindful of. What are they? Diabetes, why is that? Because it's a glucocorticoid, so it can increase the sugar. What else? Hypertension, why is that? Because of the mineralocorticoid effect. Now, some of them are selective, so that's nice. We won't have to worry about the mineralocorticoid effect. But if they are not selective, then increasing the blood pressure through water retention is something you need to watch for. And there's a third disease state you need to be aware of, or to be careful whenever you give a drug as a cortisone. What is it? Huh? What happens if you take these? What happens to your immunity when you take these glucocorticoids? Goes down, right? So if somebody is immunocompromised, it's a problem. Okay, so that's why, guys, these glucocorticoids or cortisones, we only use them for a short time. The only exception that we use them like lifetime is when you take them by inhalers. Why is that? Because they do not reach the circulation. They work locally. Okay? So they do not reach the circulation, they work locally. So that's why you see people taking these glucocorticoids like for lifetime, because they just use them to prevent COPD or asthma. Okay. Diabetes, high blood pressure, and if someone is immunocompromised, like AIDS, for example, or if they take, sometimes you do like kidney transplant or liver transplant, and then they put you under immunosuppressants. So then, if you take cortisone at the same time, then your chance of getting infection will increase. Okay. What else? What topics did we talk about? Just trying to remember. We talked about asthma, diabetes. Yeah.
Do we have to know about how they work, like by blocking phospholipase A2 or not?
Yes, sure. Yeah. So mechanism of action for these glucocorticoids. What is the mechanism of action of these? Yes, so they induce the synthesis of a protein called lipocortin. This protein inhibits what? Phospholipase, okay? Why is this important? Because it's the first step in the synthesis of all these horrible chemicals that causes inflammation, causes allergies, causes, histamine release and all that. So you block it right from the beginning, which is the reason why we use these, steroidal drugs to treat asthma, COPD, but we cannot use the NSAIDs, for example, to do that because NSAIDs block only one of the pathways, not everything. Make sense? So what type of receptors do these glucocorticoids or generally corticoids bind to? Are they GPCR, ion channels, membrane bound, nuclear receptors? Good job. Because so drugs that bind to nuclear receptors, they either increase or decrease the protein synthesis. In this case, they increase synthesis of protein called lipoprotein. If I take my own exam, I'll fail. Okay. Not funny? I know. Well, because I don't have to memorize. You have a class? I'm sorry, I didn't know that. What time? Now? All right. Yes, Sunday, 9 o'clock.